Okay, now let's talk about routers and routing tables. Remember that routers are responsible for routing packets from source device to destination device. So routers are most concerned with destination networks. The router is really not concerned with the end device itself. The router is mainly concerned with the network or the family that the device is a part of. So the router is going to keep a table or maintain a table that contains entries that will assist the router in making those routing decisions. Here we have a couple of routers, and here are their routing tables right here. Take a look at their routing tables. For simplification purposes, we'll call this network 1.0. We'll call this network 4.0. We'll call this network 2.0. This router's Ethernet interface right here is 1.1, 2.1, 2.2, and 4.1 respectively. This is a serial interface on this router on router B, and then of course an Ethernet interface on this router. The routing table itself is going to contain, first of all, the network address of directly connected networks. And in the routing table, you'll see a C indicating that the network is directly connected. So on router A here, on router A, we'll have network 1, and we'll also have network 2 as a directly connected network. In addition to the network itself, the network entry, there's also an interface entry that will indicate the interface for that directly connected network. So you'll have interface E0 and interface serial 0 in the routing table. There's also what's referred to as a metric. The metric is used by the router to determine the optimal path or the best path to the given network. The metric that we're using in this particular example is called hop count, which is used by RIP to determine the best path. A hop is synonymous with a router. So in other words, how many hops or how many routers must I go through to arrive at the given network? The metric here for network 1 would be 0, because I have to go through 0 routers from router A to get to network 1. To get to network 2, I'll go through 0 routers as well. Over here on router B, we'll list network 4.0 and network 2.0. Both of these networks are directly connected networks, and so therefore the metric on each one of those would be 0 as well. Notice I indicated the interface of those directly connected networks as well. Networks that are not directly connected must be learned by way of a routing protocol, or the network administrator would have to configure a static route to indicate the destination network. Here, router A learns about network 4 from router B by way of a routing protocol. So network 4 is listed in the routing table associated with serial 0, which is the outgoing interface to route packets to that network. And notice the hop count here, the metric that would be used would be a metric of 1, indicating 1 hop to get to network 4, or 1 router to get to network 4. Over here on router B learns of network 1 via router A using the serial 0 interface to route packets to that network. And of course, once again, there would be a metric or a hop count of 1 to get to the given network. Routers use routing tables to maintain information about destination networks. Remember, the responsibility of the router is to route packets from one network to another.